Hey, welcome to Teletype Talk, episode number 5. I am your humble narrator, Joe. So today, we've got a pretty involved patch here. We're going to delve deep into the ecosystem. So I thought we'd start with a patch overview here of what all is going on. The modules we're using are, of course, the Teletype. We are using the Telex output expander, or Telexo or TXO, as well as the Teletype input expander, Telexi or TXI. The ER301 has our sound generator, and then I'm using the Mordax data here just for display. So, beginning with the Teletype output expander, the TXO, we've got the 4 CV ports here. The output ports are generating a Quadrature Wavetable LFO, which you can see over here on the data. So if you don't know what a Quadrature LFO is, it's essentially just an LFO that has 4 different outports, and they put out the same signal, but the signals are out of phase by 90 degrees. So you can see that each sine wave here is a little bit offset from the other sine waves in time. So these can be pretty handy for a number of different applications. You could send these anywhere, really. You could send these to a filter. They're used pretty commonly in time-based effects, such as choruses or flangers, things like that, to kind of modulate the delay times. We're actually going to use it to control pitch or notes of 4 different oscillators, because I think that's a pretty good, a pretty easy thing to hear and understand what's going on. So the 4 CVs on the TXO are generating the Quadrature LFOs. We've got up here on the TR outputs of the TXO, we've got these generating trigger or gate signals. Essentially, the output expander has 4 independent metronones, so they can all run at independent rates. Here we've got them kind of synced up, but we can use those in a variety of different ways. In this case, we're actually using it to trigger the envelopes of these different notes that are being generated. Let's see. So the trigger outputs here are being fed back into the Teletype over here, into the 5, 6, 7, and 8 trigger inputs, and those are triggering different scripts. The 4 CV outputs are being fed back into the TXI. And here we're essentially, every time one of these gates fires, a script fires, we are grabbing the value of that LFO that's being fed into the input expander. We're doing kind of a sample and hold operation, and we're also using that to quantize to a custom scale that we've defined over here. So right now I've just got kind of a major pentatonic scale defined, and that goes across the range of, we've got it right now set up for 4 octaves if we're going minus 10 to 10 peak to peak. We can also change that. We've got that set up as a variable. And let's see, the 4 different parameter knobs over here actually control these Quadrature LFOs. So I've got the top knob over here set up to control the amplitude. If I bring that down, you can kind of see that decrease in amplitude. The second knob here we've got set up to control the frequency of the LFOs. So if I bring this back down, you can kind of see these LFOs get slower and slower. This third knob here is used to control the wave shape of the LFO. So right now it's on a sine wave, but as I start to increase this, we can change to kind of a triangle shape, and it kind of morphs between them. Here's more of a saw shape. And really there's a ton of different waveforms here that we can use. These are all affecting the pitch. I'll just turn this back up for just a second. And then finally, this fourth knob here is controlling the offset of these LFOs. So kind of see where you can move them up and down the spectrum, and this is going to, affect the range of the notes we play, and where and in which octave we're playing them in. Let's see. Then finally, all of these different sample and hold scale quantized notes are being sent to the ER301 over the I2C bus, as well as the triggers are being replicated here and sent to different envelopes on these sine wave oscillators. Like, for example, here. So yeah, I think that's about it. You don't necessarily need to have an ER301 to do this. You could send these outputs to any oscillator over the standard analog outputs of the teletype. And I think there are a few interesting things in here, even if you don't have a TXO or a TXI. For example, quantizing an input signal and to a given custom scale and using the sample and hold operations. So we've got a lot to cover here. Hopefully this sounds exciting. Let's get going. Let's begin by creating the Quadrature LFO. So I've got on the Teletype output expander, the TXO, I've got the 4 CV output ports connected to the inputs of the Mordax data scope so that we can see what's going on. It makes a really nice display, but it's also pretty handy for, seeing what you're doing if you've got a scope available. So to get this started, let's just start with the command line here, the immediate command line, and let's make a sine wave. So we'll do TO. All of the Teletype output expander commands are prefaced by TO. And we'll do TO dot LFO. No. TO dot OSC for oscillator dot LFO. And we're going to specify the first one. And here we're going to give a range in millihertz. So let's just start out with 1,000 millihertz, or basically 1 hertz, 1 cycle per second. We'll issue that command, and nothing happened over here on the scope. So why is that? This is probably worth spending a moment on. So the Teletype output expander CV ports are capable of a bunch of different things, actually. They can output DC voltages. They can output waveforms at very, very, very slow rates into the minutes or hours, and they can oscillate so fast that they can become sound sources as well. They're also capable of generating envelopes, attack decay type envelopes, and they can even do some of these things at once. So you can even have like enveloped LFOs or enveloped audio rate oscillators. But the important thing to note here is that, for any of these operations, the maximum voltage that it's going to put out is going to be defined by the CV value. So when you do this, if nothing happens, your CV value is probably still set to 0. So it actually is oscillating, but it's oscillating over a maximum range of 0 to 0 volts. So let's change that. We'll do TO.CV, and we'll specify number 1. And let's just set that to 5 volts. Now we can see the waveform over here, oscillating. It's a sine wave right now, oscillating at 1 cycle per second, going from -5 to 5 volts. So cool. That's from a command line. I think I actually do want to start putting these into scripts so that we can, save and recall the scene and kind of have it automatically start back up and do what we want. And I also want to start connecting some of these to the TXI parameter knobs so that we can control them. So let's see. Let's set these up, some of these things into a script. We'll put them in some of these in the metronome script to start. Right now, if I type M, metronome is running pretty slowly. It's just running at 1,000 milliseconds or every second. That's way too slow. I don't want there to be 1 second intervals between when I turn the parameter knob and when it reads the value. So let's speed that up a lot. Let's set metronome to 25, and now it'll fire 40 times per second, and that should give me a pretty smooth change on these. So let's go over to the metronome script, and let's see here. Let's do TO dot CV, and actually I think we want to do a loop here because we want to actually do this for 4 oscillators when all's said and done. We don't have 4 oscillators running yet, but let's do a loop from 1 to 4. And let's do TO dot CV. Remember I is our loop counter. And let's set that to volts, the double V, to give us a little bit more precision. And let's do TI dot param 1. So this knob right here, TI param 1. Now as I turn this knob all the way down, you can see this has gone 0 volts peak to peak. And as I start to bring it up, I've got the voltages here set to 2 volts. We've only got a display of 4 here, so it's cutting it off a little bit on the scope. But it's going 10 volts peak to peak here. Cool. Let's also wire up knob 2 on the Teletype input expander, the TXI, to control the frequency of this waveform. So I'm going to do another loop here so that we can set all 4 at once. Loop 1 to 4. And let's see here, we're going to do TO dot OSC dot LFO. So we're going to set this to an LFO rate. And we're going to affect output I, the loop counter, either 1, 2, 3, or 4. And let's set that to TI param 2. So now as I make adjustments here to param 2, it's basically stalled when I have it all the way down. And if I bring it all the way up, we start to move faster. What I'd actually like to do is set some of the ranges on these TI knobs. So by default, they go from negative 16,383, I think it is, up through positive 16,383. So let's actually set up some maps for these so that we can control the ranges. And I'd like to do these in the init script again so that these are all set up and ready to go. So let's do ti.prm parameter.map. And for number 1, which is going to control our amplitude, and we're setting that to a VV value. So let's set that from, we probably don't need 0. Let's just set it from 1 to 1,000. So from something very slow up through 1 hertz. And for the second parameter knob, tiprm.map, let's set that between 0 and 1,000. So I can run the init script now by pressing the F10 key on my keyboard. And now as we bring knob 1 down to its minimum, we've got 0 volts peak to peak. And again, bring it up close to its maximum, and we get something close to minus 10 to 10 peak to peak. And for the frequency, we should be at a minimum here. We're basically going to be stalled. It's not really moving. And as we bring it up to the maximum, we should be at 1 cycle per second. Cool. So We've actually got, it looks like a couple different oscillators going on here, but they are currently in phase. So they're all moving at the exact same rate, and they're starting at the exact same time. They all kind of look like one waveform. So let's set up the phasing on these. And I'm going to do a script with these, a different script, so that I can kind of reset this if I ever need to. So let's just pick an empty script here. Let's go to script 1. And what we want to do is set the phase of these, each of these 90 degrees out of phase. Actually, let me jump back over to the command screen here, and let's just do divide. I think it was 16,383, and let's divide that by 4, and we get 4095. So basically, we want to add an offset of 4095 to each of these. So if I come back to script 1. Let's take the first oscillator and do TO OSC dot phase for number 1, and we'll just set that to 0. For the second oscillator, we'll set its phase to 4095. For the third one, we'll set it to 2 times 4095. And for the fourth one, we'll set that to 3 times 4095. Also here, I would like to sync these, just to make sure that everything is perfectly in phase. So let's do TO. Actually, let's do a loop so that we sync them pretty much all at the same time. Loop 1 to 4. And we'll do TO, OSC, sync, I. So let's run the script now by pressing the F1 key to run script 1. You can see over here on the Mordax data that we've now got all 4 waveforms, and they are all 90 degrees out of phase, so it makes for an awfully pretty display, doesn't it? Okay, so we've got 2 more controls that we want to rig up here for the TXI. We've got 1 controlling the amplitude, 2 controlling the frequency. We want param number 3 to control the waveform. So let's set that up. Again, we'll wire this up to Metro. I don't want to run out of room in Metro, so let's actually just tell this to call another script in a loop. So we'll do loop 1 through 4. And let's have it call script number 2. I think that's our next unused one. And in script number 2, let's change the waveform for each of the oscillators. So we'll do TO.OSC.wave. And we'll do I there so that we get each of these 1 through 4. And let's set that to TI.param3. So you can see it's instantly started to change there to something else. Let's see, the waveforms. Let's see, what are the possible values here? Let me look this up really quick. The waveforms go to, I believe they go from 0 to 4,500, and every increment of 100 is kind of a perfect waveform, and the values in between the hundreds are, morphing between the different perfect waveforms. So let's set up the value range for param3. Again, we'll put this in the init script. Let's do ti prm.map3, and we'll start with 0, and I'm not sure the exact number here. Let's try 4,500. So these ti param.maps are just, essentially, if the knob goes from 16,383 plus to minus, instead of doing that when it's at a minimum, here we're going to read 0, and when it's at a maximum, we're going to get a reading of 45, and all the values in between will just be between 0 and 4,500. All right, I think we have got that set up. Let me hit F10 to run that init script again to get that mapping in place. And now if I go all the way down, I should be back at a sine wave. As I start to turn it up, we should morph toward a triangle. And as I turn it up more, we'll morph toward a saw wave into a square. And through all variety of different waveforms. Cool. The last one we want to set up here is the offset. So let me bring down the amplitude a little bit so that we can see this work a little bit better. Let's go ahead and set up our parameter mapping here. I think for this one, for number 4, we can probably just leave this at its default, but let's set it explicitly through here. And we'll run that script with the F10 key. Let's go back to our metro script, and we'll do another loop so that we set all of these at once. Let's put these in script 3. So for script 3, let's do TO, oscillator, and we'll set the center here of each output I. And let's just set that to TI, param 4. Let's try it out. As I bring that down, the center of the waveform changes. And as I bring it up, looks like it's working correctly. Great. Next, let's talk a little bit about the 4 independent metronomes that are available on the TXO. So to start talking about these, let's go back to the immediate command line prompt here. And let's just do TO. And we're going to reference one of the TR ports, trigger outputs. And let's do M for metronome. And let's do A for activation. And activation can be 0 or 1. So let's talk about TR port 1. And let's just set that to 1 to activate it. And you can see up here that the light has started to flash. So we're getting kind of a gate signal out of there. So there are also a variety of commands to set the rate of that metronome. I'd actually like to keep it kind of musical, so I would like to set it in terms of a BPM. So let's do to.tr.m for metronome. And let's do BPM. And let's do number 1, TR port number 1. And let's set that to, I don't know, let's just try 180. So you can see that the light has started to flash a lot faster. So it looks like we can activate these and also set the rate on them. What I'd actually like to do here is to set this to some kind of a tempo that we'd be able to change through a variable. So if I hit the tilde key and bring up my variable display, we've got a number of global variables available to us here. I'm going to take T, which is often used for some kind of time variable, but here I guess it could easily mean tempo, which is also related to time. So let's just set that to something. So we'll do T, and I'm actually going to set it to something quite slow. The reason for this is that, we'll see a little bit later, I'll demonstrate this. Each of these metronomes can also have a clock multiplier applied to it. So that's kind of a real-time, performance thing that you can do. But they don't have divisors. They only have multipliers. So if we start out slow, then we'll be able to use the clock multipliers a little bit more effectively. So let's set C to something slow, like 40 BPM. And actually, I want to do that in my init script as well. So let's set T to 40 here. Another thing that I did from the command line was that I set the metronome on the teletype to something very fast. I set it to 25. Let's make sure that is included in our init script as well. So I'll hit F10 to refire the init script. And we've got T still set to 40, so that's great. All right, let's create a script to set up all 4 of our metronomes up here. I think the next available script is 4. So let's do a loop in here. 1 through 4. to.tr.m for metronome. And let's just activate it and make sure it's active. And we'll do number I for the loop counter. And we'll just set that to 1. The next thing I want to do is set the BPM of each of them. So we'll do loop 1 to 4. TOTR metronome, BPM, number I, and let's set that to T, the variable, our global variable, which is right now at 40. The other thing I want to do here, because we're maybe starting these at potentially different times, let's sync all of these metronomes. So we'll do one more loop here. So syncing will just basically reset it. And if we do these all in an extremely fast loop right here, they should all be just kind of synced up together. So we'll do TOTR, M for metronome, sync, and I. So this is script number 4. Let's fire that by pressing the F4 key. And you can see now all the lights are blinking. They're blinking together, and they're blinking quite slowly at 40 beats per minute. So because we've set them so slowly, let's come back to the command line here, and we'll just take, let's do TO, TR, metronome, and multiply. Let's just do number 1, and we'll set the multiplier on that clock rate to 2. So you can see now the first light is firing twice as fast as the rest of the lights. Okay, I think we're good here. So we've got our 4 different triggers set up. We've got our Quadrature LFO, which is controlled by the 4 param knobs on the TXI. We've got those displayed on the scope. I think we're ready to actually start doing something with it. So let's quickly cover the ER301 patch that I have set up here. At the top level, I have 4 different mixer channels. Each one contains a sine wave oscillator. And that sine wave oscillator has an envelope on it. In most cases here, I'm using this skewed sine envelope, which is kind of a sine-shaped envelope with a fixed duration. And these are being triggered over the I2C bus by these SC.TR units. So this one is on port 1. If I issue SC.TR pulse 1, we'll see it fire, and it produces a sound. It triggers that envelope and lets the sine oscillator through. If I do SC.TR.P2, it's going to fire a different one. So all of these oscillators are very similar. They're all sine waves. I've got just minor differences on each of them. The durations may be different on the envelopes. On some of them, I think one of them I've got some phase modulation feedback. Another one, I think this last one, I actually have some regular phase modulation from another sine wave oscillator. Some of the volt per octave offsets may also be set a little bit differently. An octave or so off, just to make them sound a little bit different. And then the pitch is being controlled by these SC.CV units on ports 1 through 4. So we can see here, you can kind of see this line above the center. This is on port 1. So if I do SC.CV1 and I set that to say 7 volts. We'll see that line jump up above the 5 line here, so it's set to 7 volts. So that's kind of how we're controlling this patch. Like I say, if you want to use a different oscillator, you would just not use the SC prefix here. You would just do tr.p1 and just trigger the standard analog out on the Teletype. Okay, I think that's that. So the goal here is we want to read this Quadrature LFO. And I've got the outputs of these 4. They're actually going through the data, but this is a buffered mult on the data. And they're coming over here, and they're being fed into the 4 different inputs on the TXI. So what we want to do, we want to set an overall octave range for these. And I want to store that in a variable so that I can change it. Let's go ahead and use A for that. So we'll set A. I want this to be, at least for starters, a 4 octave range, as this varies from -10 to 10 volts. Let's go ahead and put that on our init script. Actually, not the init script. We've got a script over here that is set up to sync our oscillators. I think let's put it in there. So where was that? Script 1? I think so. Let's put it here. A4. That way, if we fire that script 4, we can actually change that on the fly as kind of a performance control. Let me go ahead and fire script 4. Make sure A is still set to 4. Looks good. The goal, like I say, we want to read these. We want to figure out what octave we're in, and then we want to quantize it to a custom scale that we're going to set up over here in the pattern. So right now, these are all zeroed. Let me go ahead and put this major pentatonic scale back in here. So we'll leave that at 0 for the root. We'll do 2 for the second, 4 to get the major third. We'll do a 7 to get the fifth, and a 9 to get the 6th scaled degree. The other thing I want to do here is I'm going to hit my Shift E, and I'm going to hit Shift L to set the pattern length and the pattern end. And that way we know how long this pattern is going to be. It's going to be 5 long. These trigger outputs up here that are currently working off of the metronome. I've got these routed into the Teletype inputs, the TR inputs. So 5, 6, 7, and 8. And as you may recall, anytime these inputs receive a trigger, they're going to fire that corresponding script. So as we get a trigger on 5 here, it's going to fire script 5. So let's go take a look at script 5 and set that up to do what we want. Okay. So let's see here. The first thing we want to do is kind of figure out what octave we're in. And what I actually want to do is figure out the total number of notes that we have to work with, which is going to be the length of my pattern, 5 notes, times the number of octaves that we want to cover, which I have set up in A here. So it's going to be 4 times 5, or 20. So let's figure that out, and let's store that in one of our local variables for this script. The first one available is J. So we're going to set J equal to something, and let's set it equal to, we're going to multiply A, the number of octaves, times the number of notes, which is going to be P in dot length of pattern 0. Actually, I think that's just PNL. And just to see if that's working right, let's just temporarily, let's grab one of these other variables like X, and let's just set that to J. Come back over to our variable display, and we've got 20 here. So we know we've got 20 notes available. 5 notes times 4 octaves. All right, the next thing we want to do, so we've got this LFO, the first one, coming into input 1 over here. And just like we mapped ranges for these parameter knobs, I want to map a range here. So this would normally, as we vary from minus 10 to 10 volts, it would have a range of minus 16,383 to positive 16,383. I really just want this to map from 0 to our total number of notes, which right now is 20. So let's set that up. We'll do ti.in.map. And here we're talking about input number 1. And let's set that equal to J. Actually, 0 through J. So now we've got that map. This this LFO varies from minus 10 to 10. We should get numbers from 0 through 20. Let's, again, just take a temporary variable like x, and let's see if that's happening. So we'll do ti.n1. We'll come back over here and take a look at x, and we can see that it's changing. It's kind of bouncing around between 8 and maybe 12 here. Let's increase the amplitude here, and we should start to see a bigger range for x. So that looks like it's working right, and it's giving me, up through 20 note numbers as I move around here. Good. Okay, coming back to the script, the next thing I want to do is figure out which octave I'm in. So I think I'm done with the variable j for what it was used for there on line 2. I can go ahead and reuse that. So let's set j, and we're going to divide ti.n1. Remember, that's between 0 and 20 now, and let's divide that by a, which is our number of octaves. And again here, let's set x equal to j just so we can kind of observe what's happening here. So as I come back here now, and we're kind of watching the green line here on the scope. Looks like it's bouncing back and forth between 0 and 4. Let's decrease the amplitude quite a bit. And actually, let's change the offset. And you can see x is now around 0, or the first octave. Up through here we get into 3 and 4. All right, now we want to actually determine a note number within that octave. So let's use our other local variable for the script, which is going to be k. And what we want to do is figure out the note number that it's landed on. And we want to map that. We want to get a number between 0 and 4, and we want to use that to look up one of these pattern values to actually set our note number. So let's come down here, and we're going to set k, and in this case we're going to use the modulus, which is kind of the remainder if you do a division. And let's set that equal to ti in the first one, and we'll divide that by the length of our pattern, so pn.l0. And now we actually want to set the note number on our destination. So again, we're going to the ER301 here over the I2C bus. I'm going to do SC. If you're not using an ER301 and you're just using a bunch of other tuned oscillators, you can just leave the SC dot off. So we'll do SC, CV, and let's see, we're setting it for number 1 right now, port 1. And what I want to do is I want to add an offset for the octave, and then I want to add the note number that I look up. So let's put a plus operator in here. And we'll set it equal to a voltage. This is a voltage negative 10 through 10, and we're going to set that, we already determined our octave, and we set that in J. So we'll set that equal to the octave that we found in J. And then we're going to add that the note number that we look up in the pattern. So let's do N for a note number. And we're going to set that equal to whatever we find in pattern number 0 at index K we determined up here. Very good. And the last thing we actually want to do here is fire this trigger. So let's do SCTR pulse 1. With my offset knob here, I should be able to change the octave. With my amplitude control, I should be able to change the range of the octaves that we're hitting. Very good. So now we have a baseline for the rest of the scripts, which are being fed into 6, 7, and 8. Let's go ahead and copy all of these lines. Alt-C to copy. We'll move to script number 6 and paste these in. And now I just need to make some changes to the numbers that we're referencing. So the first line should still be good. Here we want to change our input that we're referencing to 2. On the next line, we'll change the input that we're referencing to 2. On the next line, again, we'll change the input that we're referencing to 2. Here we'll change the CV port we're referencing to 2, and the trigger pulse to 2. So if I turn the volume back up, I'm expecting that the green wave and the blue wave will now be triggering the 2 of the oscillators here on the ER301. We can change the waveform a bit. Great, let's move on to script number 7. Alt-V to paste these lines in, and again, we'll just change the references. This first line is still good. Here we're going to map TXI input 3. We're going to reference TI input number 3. TXI input number 3. Here we're going to change the CV voltage port to 3 and the trigger port to 3. Back here on the ER301, you can see if I go over to the third mixer here, we've got the SC-CV unit set to port number 3. And we've got this envelope being triggered by SC-TR unit on port number 3. Let's turn the volume back up. We should have 3 oscillators. Sounds good. Let's do the last one. We'll move to script number 8. We'll do a paste. We'll map number 4. Change the input reference to 4. Change this input reference to 4. 4 and 4. If I turn the volume back up now, I should hear all 4 oscillators. Let's come over here and change our custom scale. So let's take this third note here, which is the major third. I'm going to use my left bracket key to make this a minor. Let's actually make it a fourth. These oscillators are all tuned to C, so that should be an F. Let's change the tempo up a bit. Let's move T up to 50. And I believe my script to reset these metronones is here on script 4. I'll hit F4. Let's change the multiplier on how about number 3 here. So we'll do TO, TR, metronome, multiply, 3. And let's set this to 3x. Another performance control that I have available here is if I hold down my control key and press the F5, 6, 7, or 8 button, it's actually going to mute that entire script. So let me do Control F5, Control F6, Control F7, and now I'm only hearing script number 8. So I can bring these in and out by holding Control F5 through F8. Let's turn the first one back on, Control F5. All right, cool. I think that's about it. So in conclusion, what we've done here, we've set up the TXO to generate a quadrature wave table oscillator. We've set up the TR ports to generate 4 independent metronones, over which we have some control over the tempo and the multiplier for each one individually. We've routed all of these things back into the Teletype, kind of a feedback patch here, really. So the CVs are going to the TXI inputs. We're reading those, and we are determining an octave based on their values, and also a note number. And we're using this pattern here to define a custom scale. So we're basically taking those and determining a note number in a particular octave and matching the scale pattern. We're taking the triggers and feeding those into the Teletype trigger ends and using those to kind of fire off a sample and hold effect, at which point we do this quantization here and also relay that trigger port to the ER301. I hope you've had fun here. Hope you've learned something and maybe something you can, some ideas that you can use. There's a lot of use for all of these different things. So until next time, take care. This is Joe signing off.